Good morning. Today we're going to be talking about the universe and the components of that universe, which is our universe. Same universe, no, not different universes. However, some people believe that there are multiverses. I know Spider-Man does, or whoever out there, but we're going to talk about what we know in science, which is our vast universe and our place in it and some characteristics of that universe. So let us begin. We're looking at components of the universe. So this is 8.8a, Texas TEK, and it's describe components of the universe, including stars, nebula, and galaxies, using models such as the HR diagram for classification. I'm going to break down the HR diagram in a separate lecture because I think it deserves its own mini lecture, and so I will do that at a later time. However, let's get to it. And first I wanted to show you a cool little video because as space is vast, and the universe contains everything that exists, including that vast space, that empty space, which makes up most of the universe. That is make sure that gets in your notes. And the matter, which is everything else. So you're talking comets, asteroids, planets, moons, stars, galaxies, and all in between. So while there is a bunch of empty space, the universe does make sound. So to some of that sound. I hope you'll be able to hear it. So they use waves of the EM spectrum to gather a bunch of information from space. And so just inside our solar system, clearly we have a lot of celestial objects. You probably won't be able to hear this. So I definitely recommend, I will share this link to this PowerPoint where you can actually listen and hear the sounds that these different bodies make. So we have Jupiter, a moon, the sound that moon makes, Neptune, sounds a little bit like the ocean. The rings of Uranus, very cool. Sounds like church. Saturn's is creepy. It's almost like you're driving in a tube and the sound the cars would make echo in a tube. Saturn's rings. The Song of Earth. The sphere of Io, sphere of 10, whatever. And everyone's favorite, Uranus. That's right. Sounds like airplanes screeching across the sky. And Earth. All right. So we're going to jump in. As I've already told you, the universe is everything that exists, including space and matter. And matter is anything that has mass and takes in volume and takes up space. And as we know, energy can change matter. Most of the universe consists of empty space. I've already told you that. It's a very key fact there. Yes, the masses of objects in the universe vary greatly. So let's talk about, so here's what we're going to do. There's a acronym that I have that will help you. It's UGS SPM, and that will help you to categorize the things in the universe from largest to smallest. U starting with the universe. And then we go into, so it's U, G, G, S, 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 P, M. UGS, SPM. Okay? So first is universe. The next one would be galaxy cluster, because sometimes, they'll have galaxies, and then you'll have galaxy clusters. You'll have stars, and you'll have star clusters. And you always know that a cluster is definitely more than just a galaxy. It's like an ant in an ant cluster. What would be more? Clearly, an ant cluster would have more members, if you will, than the singular ant. So UGG would be universe, galaxy cluster, galaxy. So let's talk about some of these important galaxies. First of all, before we do that, we need to know what a galaxy is. It's a collection of dust, gases, and hundreds of billions of stars. Not hundreds of stars, not thousands, not millions, but hundreds of billions of stars. And so when you think about that, and then you think about the fact that there are hundreds of billions of galaxies in our universe, we're talking a big ol' universe. Okay? And does anybody know what type of galaxy that you see on your screen right there? Yes, correct. That is a spiral galaxy, just like ours, the Milky Way. But anyway, let's keep going. There are different shapes of galaxies, and that's how galaxies are categorized. They're not categorized by temperature. They're not categorized by the amounts of stars. They're simply categorized by their shape. So, and that is the lies of it. LIES. So we have lenticular, irregular, elliptical, and spiral. Lenticular, irregular, elliptical, and spiral. Those are the four main types of galaxies that you may read about on your star test. The one that is most important to us is our spiral, disc-shaped, pinwheel-looking galaxy. Notice how all of those terms describe how it looks. So that is how we categorize galaxies, by how they look. As I've already talked about, our Milky Way galaxy. And another very important part that you should know is the reason why we cannot see the entire shape of the Milky Way galaxy is because we are inside of it. Just like you cannot see the entire shape of your house because you're inside of it. If you were to get out of your house, maybe get in a helicopter, fly up, you could see the shape of what your house looks like. So until we are able to travel at greater than the speed of light and warp out to a far enough distance that we can actually see our galaxy and its grandeur, which, clearly we cannot at this time. We are stuck on our third rock from the sun. It is what it is. So the reason why we understand the shape of our galaxy is because of our EM spectrum and being able to use these different rays to gather information about our galaxy. So we have deducted that our galaxy is shaped like a pinwheel. And another reason why is because we've been able to look at other galaxies with our awesome telescopes and see what they look like and compare ours to theirs. So we live in the Milky Way galaxy, which is spiral / disc-shaped / pinwheel-shaped. There it is. And in our galaxy, we have hundreds of billions of stars. And a star is a sphere of matter with a density and temperature great enough to cause a nuclear reaction at its core. And that nuclear reaction fuses hydrogen to helium, H to He, number 1 on the periodic table to number 2 on the periodic table. So what's happening is the H hydrogen is flying around, smashing into each other in the sun. This is just very, very, very basic. You can go to a high school or college level class and they'll talk about it more scientifically and at a greater complexity and a greater rigor. But That basically is what is happening. And as that H is smashing together and creating HE, that creates a thermal energy that we feel from Earth. Just imagine that for a moment. Let your brain wrap around the fact that what we feel when we step outside of our house and we look up at that sun and we're feeling that thermal energy, that is simply because of the nuclear reactions that are happening, that H to HE. And you're talking many countless atoms of H converting to HE through that reaction. So that's why we feel what we feel when we go outside. It is made of hydrogen and helium, as I've talked about. It emits light. A star's luminosity is how bright it is. So luminosity is brightness. Luminosity, brightness, same thing. The closest star to Earth is our sun. That's it. The next one is 4.2 light years away. So our sun is the closest star to us. And so that's the reason why it looks so bright in the sky and it's so big, is because it's closeness. Once we do talk about the HR diagram, and once we do look at life cycles of stars, and we actually take a deeper dive into stars, we will know that, we'll realize that our star is very, very average. There are lots of stars smaller and many bigger. So our star is medium-sized star. The next closest star, Proxima Centauri, 93 million miles away. So, nope, just kidding. 93 million miles away, what I meant is for our star. The next closest star is very, very far. That's the reason why they use light years in space, because let me just break it down to you like this. You're talking about 25, 300, 3 or 000, 000, miles away to Proxima Centauri. So we have to, if we're ever going to get out of our solar system, go and see the universe, we are going to have to figure out how to travel at a very, very fast pace. Like light speed is almost not fast enough, because if it's going to take you 4 hours or 4 years of flying in a spaceship to achieve the very next closest star, wow, do we have our work cut out for us. So all you young scientists out there need to figure out how to get our species to travel at unbelievable speeds so we can check out this awesome universe. Stars are born in nebula. Nebulas are clusters of dust and gas. It's a collection of dust and gas in space, but it is the birthplace. It is where stars are born. Understand nebula. Definitely know what nebula means. Check out nebula on the Googs, on the World Wide Web, and look at all the different pictures and cool, awesome shapes and colors that nebulas are. They're beautiful. They're absolutely beautiful. So definitely check those out. So nebulas are where stars are born, and this star life cycle it's very truly a cycle, because in the death of a star, a nebula is born. A star dies and it becomes the womb for new stars. So that's the reason why many scientists believe our universe is growing, because where one dies, many are born. So when you think about that, it's like if you step on an ant and then you look up and then there's 4, 5, 6, 10, 20 of them that have spawned in that one ant's death, and then you stomp on those, and then there's like it just keeps growing and growing. And so it's kind of what happens when stars die, new stars are born. And just a reminder of what a solar system is. So here, let's go back to UGS, SPM. So far we have universe, galaxy cluster, galaxy, star cluster, star, or star cluster, solar system, and then star. Okay, so we're at the solar system portion. A solar system is a collection of celestial bodies orbiting a star. Celestial bodies are objects found in space, such as planets, moons, comets, meteors, asteroids. Some solar systems have dual stars in them. Once in a while that'll happen. But usually a solar system is just one star. That's why a star cluster would be a greater volume than just a single star. So UGGS, UGGSSSPM. Universe, galaxy cluster, galaxy, star cluster, solar system, star. Okay? Then planet, then moon. So that's your entire acronym. Make sure you understand it from largest to smallest. The STAR test will ask you about the varying sizes of things in the universe. So you need to understand that, and hopefully that acronym will help you. So there's a cool video here. I'll definitely share it with you in the channel here. You'll be able to click on it and see and watch these videos, but for time purposes, we're not going to go through it now. In case you didn't know what asteroids, meteors, or comets were, there's some definitions. You can write those down, jot those down, just so you can differentiate between the three of those. There's a comet called Halley's Comet that zings around our solar system from time to time. I've had an opportunity to see Halley's Comet going through the night sky. You guys weren't born yet, my young 8th graders, when I had the opportunity to see it. But it's cool. During the night sky, you can definitely see that there is an object in the sky with a tail, and that tail is because a comet is made of ice. That's the gases being emitted from. They're all traveling so fast, and so yeah, that's a comet. And then of course our planet, the Earth, is a celestial body that orbits our star, the sun. And then of course we have our moon that orbits us. And so that's pretty much the end of that information there. But I want to take a moment to make sure that we understand a few other key things before we go. So we went through nebula, we went through solar system, we talked about our Milky Way galaxy. Our location on our Milky Way galaxy, I don't know if there's any other graphics that I can show you here. Let's just take a peek. It's going to kind of back up a bit. So, all right, so let's look. If you're looking at our Milky Way galaxy and you can see the center of our galaxy, which is that light in the middle of the screen that you see here, we are actually not located anywhere near there. We're like halfway down one of the spiral arms of our Milky Way galaxy. So we're kind of around the outside. That's our location, our solar system's location. So we're not in the middle of the galaxy. We're halfway down one of the spiral arms. So that is very testable. Make sure you have that information. And probably the one other thing I want to talk about before I end this lecture is there's two phenomenons that happen. There's redshift and there's blue shift. Let me see if I can bring up really quickly so I can give you a somewhat of a visual if that helps. So let's look up redshift, blue shift. Okay, great. This can work. Let's find a good image here and go with it. Yeah, well, I like this one. Okay, help me. Let's look. Open link in new tab. Come on. All right, so we're going to go with this picture right here. When we look out in space and we use our telescopes and we use our EM spectrum, we look at objects we look at different stars, and we are noticing some things. We notice that most everything is red shifted, and that means things are moving away from us. And that adds evidence to the Big Bang Theory that scientists believe, where the Earth was created by a singular explosion, and that our Earth is still expanding, and if or not our Earth, our universe is still expanding, and so when we look out, we see a lot of things shifted to the red aspect of the EM spectrum. So when we see red shift, we see that objects are moving away from us. The opposite of that would be blue shifted. And if we see something shifted towards the blue end of the spectrum, that means it's coming towards us. So those are two very good terms to understand: red shift and blue shift. To wrap it up, redshift, when we look through our telescopes and we see things shifted towards the red end of the spectrum, we know that those objects are moving away. And then things that are moving towards us, those objects would be shifted towards the blue end of the spectrum. And that's it, friends. 8.8a Science Teak in the books. And we will see y'all next time. Boom. We are